So thank you so much, everyone here, for being here. It is so great to be with you all and meeting you with you all here in CCFest 2023 edition. And we're going to talk about a bit about GIF encoding and the adventure we went through in the last summer to be able to finally get GIF encoding working natively in p5.js, which was a long due task for everyone that knows the struggle to just have a simple work in progress sketching up and running in Twitter or something, or Mastodon, whatever you want to share it. So we're gonna go through each of the steps that you need to take in order to solve this problem, right? So yeah, let's just get started. So who are you again? I'm Jesus, digitally known as Hesi RGB, whatever it is pronounced, I don't really mind. But yeah, that's my handle mostly everywhere. I'm a designer, I'm a web developer, I'm an animator, I love digital art in general. I've worked mainly as an animator, as a mathematical animator, which means like I've worked with channels like Veritasium, if you're familiar with those. For example, doing mathematical animation stuff to show like cool stuff with math, and you can check those videos out. And also I'm working at the Reducible channel, which also talks about computer science stuff, which is very, very nice. So it's very cool to be able to work from that. So that's mainly what I do. And last year I was able to contribute to the P5 library in order to make this function. So we're gonna talk about that very quickly. So we're gonna start with the solution, with what is that we are building more or less today. So if we click here real quick, I can check that everyone is in here still, and we can see the sketch. So we have our lovely sketch here, very nice. And we have a circle. This circle is lovely, but let's actually make this a bit brighter. So we can, actually that is our canvas. And let's make this a bit bigger, because why not? We're feeling extra fancy today. And let's make this circle move in some way that is kind of interesting right now. Why not? For example, we can just, I don't know, take the frame count and for the X and Y positions and the Y cosine of the frame count. And that would make it so the circle is literally shaking in a corner, which is very much how I feel right now because I'm very nervous. But well, we can make things through to make it a bit more calm, right? For example, we can, width divided by 2, we can put it in the middle, which would be at least nice. Height divided by 2, and we add that. We can format that code. And so essentially we have now the circle, at least in the middle, is shaking still, so we have to make it a bit more calm. For example, we can divide this by some amount, and this would make it so that it's moving more slowly, but it's now not moving at all, kinda. Actually, it's moving, but in a very short motion, so we can scale that motion a bit. Like that, and now it's a circle moving in circles. We can make it a bit faster so it's not that lazy. Right, so yeah, it's a circle moving in circles, a very natural thing for a circle to do, right? So if we're happy with this animation and we wanted to save this actually and share it to Twitter and show our friends how excited we are about this animation, we'd have a lot of problems before all this, because this is no easy task. We'd have to import some random function or some library, CC capture, you know, all the stuff for those people that actually have gone through that. My personal workflow was like, after drawing all this, I would like call the save function here, pass like a frame and like an index in here and whatever. And then I have like my downloads folder full of a lot of PNG frames, not ideal. Then we have to like get all these frames in like Premiere Pro with input sequencing and get that into a GIF, or use FFmpeg if you're feeling extra fancy, and then you can use FFmpeg to make whatever animation you have. Cool, but not ideal again. I just want to share this to Mastodon, to Twitter, to whatever, right? So we implemented what is called a revolutionary thing, which is called a function, and is save GIF. And we pass in circle gif, for example, and how many seconds we want to download, for example 5, and we hit that. It saves the frames, it renders the frames, and it downloads, and it works, and we have it, and we have a GIF that it works, right? So that is actually incredible. We're gonna go through all that. So if as 2 notes. Right now, if you do this, you'll see there's like a black frame at the beginning. So Dave very very kindly fixed that, the one in the talk before. Thank you so much, Dave, for all your work. You're incredible. He fixed that, and he also made it so that we could call save GIF within the setup function, because I could not make that to work for some reason, and we had to make like a quick mouse press, like if you press the mouse it saves the GIFs or whatever. So yeah, that is how it would work before, but now we can have it just in the setup, and in next iterations and the next versions of the P5 library, all these will be continually integrated and it will work flawlessly. So yeah, that is what we're gonna tackle today. How to build this function, essentially, right? So let us get out of here and continue. Also, but I completely forgot my my slides are in here. We're here right now. So a very quick primer into what GIFs are, in case they are a very unlikely case that you don't know what a GIF is. It's an incredibly old format, like 34 years old at this point. Like 34 years old for a piece of software is absolutely ancient, arcane. It's palette based and is lossless. It's actually a lossless image compression format, which involves a lot of things, but essentially that's, and it's like a lighter format of a video, if you will, right? Like it's a video, but it's not a video because you cannot control the playback usually and stuff, but it moves. It's not an image. It's weird. Like it's in a very weird position in that. And unfortunately, it's as stated by the author, it's pronounced like GIF. And that is a fact that I very kindly but very strongly disagree. So we're not doing that here. So essentially, we're going to talk about GIFs today, not GIFs or whatever that is. So why GIFs? It's an excellent medium format. It's an excellent work in progress format. It's true and tested. Like your grandma shares GIFs throughout the family group. Everyone loves GIFs. Everyone like feels nice about GIFs, right? So, and because of that, most web pages are comfortable using those. And that is also a thing that when creative coders want to share their stuff, they usually want to share it in GIF format instead of like a video, because for example, Twitter or Mastodon are not great at dealing with actual video. So GIFs are a bit better in that regard. So that is why we're focusing on that. Also because the solution for video is actually already implemented. So how, right? We will develop a tool that fits within the P5 ecosystem, allowing users to very easily save GIFs out of their sketches. That is the main goal that we had in the Summer of Code last year, in which I participated. So before writing any code, I just made a bucket list of all the things that I wanted this tool to have. So it has to be fast, like as fast as possible, like blazingly fast. Otherwise, it doesn't work, like it's broken. It has to be very easy to use. It has to feel native to the platform, as in, if you just look it up in the P5 reference, you like see it's one single line of code and you copy paste and it works and fine, you're done. That's beautiful, gorgeous. But otherwise, it would be incredibly hard to justify this. And also, if you like feel like you don't even look it up, but it's like, I want to save a GIF and I've never looked it up, but it's like, there's a save GIF function and you probably pass in the number first instead of the file name, whatever, but it feels native, right? It has to be responsive. This means like from a technical standpoint, it must be an asynchronous process. And that is if I, for example, mess up my sketch and I want to download this and then I have to like deal with this massive sketch that needs to render until the end before I can do any changes or whatever. No, absolutely not. We are doing this so it's very responsive. If you mess up, you just reload, you don't lose any work, it's fine. So it has to be that. And one little thing, but very, very subtle, but very important, it has to output small file sizes. For example, Twitter's file size limit is 15 megabytes. 15 megabytes is tiny, and GIFs can get absolutely massive real quick, like 100 megabytes, 200 megabytes for the lamest GIF. So it's like, we need to take that into account somehow. So those are the things that we will focus on, and let's see how we'll build this. So a bird's eye view, right? We can, how would we go about this if we had to deal with this problem as of right now? So essentially, we'd have to gather every frame from our animation. That is, yeah, we have our animation, we have a specified time, for example, and we convert that into a number of frames, and we gather those frames somehow and store them in memory or however. Then we generate a global palette that is by design. The GIF specification tells us to do so. We'll talk about that extensively next. Then we apply the palette to every frame, which means just convert the RGB values from the actual frame, the metrics it is, into indices from that palette. And then we're gonna smash holes whatever applies, which is my favorite part, but it's so cool. That means like using transparency tricks in order to further reduce the file size. Then we encode each frame, which is done basically via a library that is already written which is GIF-enc by Matt Delorier. And essentially, finally enjoy. Like if you don't enjoy the process, it won't work. Like the algorithm doesn't work. So you have to enjoy the process. So we're gonna make sure we enjoy. All right. So let's continue. Like how do we gather the frames? So we can, for example, save a frame every n milliseconds. If our frame rate is like 30 FPS, for example, each frame takes 1/30 seconds to render, so we could like download or save a frame every 1/30 seconds, but that is not true in every case, because if your sketch is very busy, for example, what is the actual frame rate? Like if it takes like a minute to render a frame, it's like a minute per frame, or like it doesn't make any sense, right? And also frame rates are not consistent. For example, if we have a simulation in which there's like a bunch of squares like spawning, if we have a bunch of squares at first, like a small number, it would run fast, but as the animation goes on and more squares accumulate on the screen, it will run choppier and choppier and slower. So it's not consistent. Essentially, the most intuitive thing, but this is just my thought process as I was developing this, we need to wait for every frame to finish and immediately save it afterwards. We do that via the redraw function, which just runs the draw loop once, one single time. So we redraw and then immediately save the frame. If it takes like 1,000 years to render that frame, I don't care. I wait for 1,000 years and then immediately save. That would be a long animation, but that is another topic. So that's how we gather the frames. Next, we're gonna generate a global palette. Okay, so why global palettes and what are global palettes and what is all this palette thing? So this is by design. We need to comply with the GIF specification. The GIF specification tells us that every frame needs to be referencing a palette, whether it's local or global, that it can take its colors from, right? Because we're not storing RGB values, we're storing different kind of values, we're storing indices. So in this case, we can make local palettes or global palettes. This palette, whatever it is, local or global, it must have like 256 colors only. Of all the 16 million possible colors that there are in like a 8-bit image, like it's absolutely massive. So we need to shrink that space into a very, very tiny space, subset of all the colors. This meaning for local and global is very simple. So a local palette would be a palette that is tailored to this specific frame, and so each frame would have its own palette. But that is very wasteful, because if we had like 100 frames, then we have like 100 palettes. And even though they are only 256 colors, there's no need to store all that data. We can make a global palette that every frame references back and we have one single palette and like 1,000 frames, and we don't, and every frame is referencing back this thing. So that is great. We're gonna make a global palette and we're gonna generate it, because there's like a default palette that has a weird representation of every color, more or less. But yeah, again, not ideal. This would make for like very muted and desaturated GIFs, because the colors are not approximating very well. So we're gonna generate our one tailored to our animation, which is not that hard and yields absolutely incredible results. How do we generate it? So essentially, we have to take into account the whole animation and all the colors that are present in our animation. So we go through every frame, we go through every pixel in every frame, and make a list of all the unique colors that there are throughout our whole animation, right? Once we are done with that, we can sort them by frequency. That is how many times they appear in an animation. We can sort that out. We can use this ranking in different ways. It's like more sophisticated and less sophisticated. In this case, we're scoring like if there's like 300 frames, for example, as we just downloaded, we can make a score of how many times each color appears throughout the animation. If it appears in 3 frames, it's 3 out of 300. If it appears in 255 frames, it's 255 out of 300. So that score already gives you like a percentage of I appeared a lot, I am very important, versus I don't appear a lot, so I'm less important. So this will make a list of the colors, and we just take the 255 most important. We're gonna reserve one single color for the transparency trick next to here. I'm glossing over a ton of details here. There's like color quantization and lots of math involved. I didn't want to get into extreme detail because otherwise we would be here like forever. But you can check that out in my blog post, in which I excruciatingly detail very every step of the way, right? You can have all this in and I'm sharing this in the chat again. So after we have a palette that we're happy with, because we are considering every color and it's tailored to our animation, now it's just a matter of applying this palette, right? This is already a function that is not exactly coded by us. It belongs to the library we're using, that we'll talk about in a bit. But I wanted to explain exactly what it is, because it's a very simple concept, and you can see the image here. It's just transforming the RGB values from the frames into index values, and we're just referencing the index of the colors. That's it, like a mosaic in which you can color, or these little kids' drawings in which it indicates what color needs to go here. It's really that simple. So as you can see, the lighter purple maps to 4, and the lighter yellow maps to 7. How the map works is just a very simple Euclidean distance. If these are points in 3D space, we can just take like, that would be like the cubic root of the squares of all of the add up of the sum of all the squares, and then you can have that, and that is like the distance. And however color is closest, we just substitute. You can see here why the default palette would not work, because if the colors are very far away, it would have to substitute those for whatever the closest color is, but this close color is not really that close, so it wouldn't look as good. So yeah. And this is the last trick. By now we could be done. Like we could just dump these into the GIF encoder and encode this thing. But even though we could be done, this transparency optimization trick is so cool that it cannot be like skipped. It is very nice. So what we do is essentially remove what's similar from one frame to another. We take a difference of the frames and say what is equal in color from one pixel to another, or in this case the indices. All right. So we remove whatever is similar. We tell the GIF encoder, hey, take this encoder color that we talked about before. These, for example, let's just take like a very random red that doesn't appear in animation. We put it there, and we tell the encoder, hey, whenever you find this value, treat it as actual transparency and take the color of the frame before you at that coordinate. So as you can see here, from frame to frame, we kind of get this stepping, we keep removing stuff. Actually, it would remove the colors. Now that I'm thinking of it, it would remove the colors. Like the purple and yellow would be removed at the first step too. But well, you get the point, right? What we end up with is images that basically are completely transparent, but have the tiniest islands of pixels that just represent the change of these objects moving. For example, if the circle is moving like up by 3 pixels from one frame to another, it would just show the difference, like a very little arc, showing that this is what it changed. And that is how we stacked up all the frames, and it actually looks like it's moving. Where what is actually happening is just a slideshow, a very fast slideshow of all the frames going on, but with tiny little differences. And why this is cool is not directly obvious, but it's because the GIF encoding algorithm uses the run length encoding algorithm within the whole thing. There's lots of algorithms, but this is one of them, which essentially means counting a lot, counting fast. So if you, the clearest example is if you have like 5 apples or something, you don't say I have 1 apple and 1 apple and 1 apple and 1 apple and 1 apple. You say I have like 5 times apple. That is essentially what run length encoding is. Whenever you find the same instance of the same object all over and again, just substitute all that by the number of things that you find and the thing itself, so you can reference and unravel it later when decoding, right? So that is essentially what you can see, that if all the frames are filled with this transparent color, because everything should be similar unless it's like completely random, this actually gets the file size down a lot. So we're keeping that in mind. Like, we want to share this to the internet, and the internet has limits, so we're gonna keep it within those limits. So yeah, summing up, we have here the map of the whole thing. Again, I talked about this library, GIFenc by Matt Delorier. Incredible, super fast, and it's very nice. And we can see here what actually the things that we coded and the things that are given to ourselves via the library. So we have our sketch up top, and we need to gather the frames ourselves, and we need to generate a global palette ourselves, in which I spent a lot of time on. Then we apply the palette via the function, which is already written, very nice. And then once we have the indexes, we just smash holes wherever applies, and that is made by ourselves. Then we have these frames that are prepared like indexed frames, and also with transparency optimization applied. And then we pass that into the GIF encoder, which actually is not written by us, is written by Matt, which is incredibly fast, and that is why it works so nicely. So the goals were mostly achieved, in my opinion. Given any sketch, we can successfully render GIFs easily, quickly, and conveniently. We don't need to hook up external libraries that can feel sometimes intimidating. Like, it can feel intimidating even to me, even I've worked for a long time in this. And file size is relatively small, and render times are not too long. Like, at least we have some feedback as to why what it's doing and when it should be finished. So that's very nice, because other libraries didn't have these pieces of feedback, and I think that those are very important for people to know what is actually going on. It's just very simple. So yeah, that's basically it. Again, I'm glossing a lot of over a ton of details, but special thanks to Devanshi Raj, my mentor, Dave Pagurek, thank you so much, Dave, and Matt Delorier, for their continued support and valuable feedback and help. They are absolute titans on this. Massive props to the Processing Foundation for making this possible, for making the CCFest event possible. And thank you for watching this, for attending this, for whatever is going on. So thank you so much. You can find me at all those links. And yeah, there's like 5 minutes spare. Went a bit fast, but I want to make sure that I didn't spend my time. So if you want to make any questions or something, we're happy to be here. Thank you so much.